Hello everyone, welcome to our tutorial on building a document-based Q&A system using LangChain, Pinecone, and OpenAI. In this video, we'll guide you step by step through building and deploying your own chatbot application on Streamlit's Community Cloud. Let's take a quick look at the demo of our application. Here's the user interface, the homepage of our application. It's publicly accessible through Streamlit using the provided link. So here the user can browse files into their local device and upload it. For example, I'll be uploading my own resume in here, and it says click to process your file before asking questions. Okay, there you go. There you process your file and you can see the file contents. And now you can ask the questions accordingly. What is the summary of this person? It says the person is a freelancer AI and ML engineer seeking to join a dynamic team to build successful algorithms and predictive models. It seems pretty accurate. Let me ask something more. What are his top skills? Proficiency in programming languages such as C++. Oh, interesting. The responses looks quite accurate. All right, now that you have seen what our applications looks like, let's roll up our sleeves and start building this thing from the scratch. So before we dive into technical details, let's briefly discuss the key concepts we'll be working with. Prompt engineering, similarity search, vector database. What is prompt engineering? It involves crafting effective prompts to guide the responses of a chatbot model. What is similarity search? Enabling us to find documents similar to a given query. Is vector database? It's used for storing and indexing document vectors to facilitate efficient retrieval of information. Don't you worry, these concepts will make much more sense as we move on to the implementation. We'll see the system architecture, which gives an extensive view of the flow of our application. For example, here you can see the user writes a query and uploads a file. The retrieval system looks for the similar information in the uploaded files, and based on the user query, it then returns the matching data points, which is passed on to the model GPT-4. The GPT-4 model performs natural language processing on the user query obtained and the information collected, and then generates an accurate response which is displayed to the user. So to get started, make sure you have accounts set up on OpenAI, Pinecone, and Streamlit. You'll be requiring to generate API keys for OpenAI and Pinecone, which we'll use later in our code. After generating the API keys, you can store it in the Streamlit secrets and use it in the code without exposing it. Let me show it to you here. You can go into the Streamlit's app settings. In the secrets section, you can specify your OpenAI API key and Pinecone API key in this particular format. And with the help of st.secrets, you can assign those keys into your code. Now let's move on. Now, since we have set up the environment, let's move on to writing our Python code. So our code flow begins with loading user uploaded files, such as PDFs or docx documents. These files are processed to extract relevant textual content, which is then converted into a suitable format for storage and analysis. So for example, we'll be creating a process button as we have seen in the demo, which takes in the user input, like it says if the uploaded file is none, then please upload a file first. And if the uploaded file is already there, then it goes into the process and uploaded on our vector database. And while processing, we use the LangChain features to load the documents. If it's extending with PDF, we load it using py PDF loader. If it's a docx, we use a docx to txt loader. Next, we pass the process data to Pinecone where embeddings are generated to represent textual content. These embeddings can later be retrieved for information retrieval tasks. And this is the Pinecone interface. So once you have processed and uploaded your document successfully, you can see it here and you can see my index name, which is like a document. And the vector count here, it represents the embeddings and the number of text that has been generated. And moving forward, we then create a prompt, which is like the crucial aspect of our chatbot application. And you can see like crafting effective prompts is crucial as they guide the model's responses to ensure they are concise, understandable, and relevant to the user's query. The more you guide it, the more you direct it for your model, the better and the accurate responses you'll get. And then we used again the LangChain framework to assign a retrieval chain, wherein you can see these particular chain is very much accurate for my use case. And you can find a lot of different variety of chains available on the LangChain documentation, which you can use based on your own use case. So here, in this case, the retrieval chain, it asks for the parameters like LLM, which is my model, just basically I have assigned to be GPT-4. Retriever, it gets the retriever from the Pinecone and the prompt that we just created. Finally, we incorporate a chat input where users can ask questions and receive answers from our chatbot. Let me explain you the conversation flow here, which has been created using Streamlit feature. You can see the format wherein st.chat_message, it defines the role, and in st.markdown, the content has been defined. So when the chat underscore input is on and when the user asks the questions, it understands the format that the role is user and the content is query. Similarly, for our AI response, the role will be assistant and the content will be the results. And there you have it. Good to go. Your application is all ready. So you have learned how to build a document-based Q&A system using prompt engineering, similarity search, and a vector database, and deployed it on Streamlit's community cloud. We hope you found this tutorial helpful and are excited to see what you create with this knowledge. Happy coding. Thank you.